So you will see another example of top-down approach. We'll work with another example of what are the code we have previously done, right? That was the top-down approach. We'll take one example. So what are the code we have written? We actually created a array memory, and then the base condition if I less than 0, then return 0, right? And the other one is else return max of, like if there is a function, then I minus 2 if you included this and the num of I, right? Or if you're not included this, then I minus 1. So these are our functions. So we'll take the example of the second example, right? What are the second example was given to the lead code. That particular we can take, that is 2 7 9 3 1. So we'll work with this. This is the input given. So now you actually need to calculate like 0 1 2 3 4. So you actually need to calculate f of 4. So either I can write this f of 4 or I can write this f of like 2 7 9 3 1, the square bracket of this. Both way we can go the recursive tree. If I'm writing this, means I have this much number, I have access to this much number. If I write it to the round bracket 4, means I am at the 4th index. So prior to 4th index, I can access any number, right? So we'll write this. 4 means like you have 0 1 2 3 4, right? So if I've given 4, means we are talking about this element. So if you are talking about this element, we can access all those things before this, right? So we'll go with the f of 4. Now we have a memory as well, right? That is length plus 1. So length is 1 2 3 4 5, right? 1 2 3 4 5. So now we'll have a memory array. The memories array actually is the number of length plus 1. So we have this till 0 1 2 3 4 5 6 elements we have, right? This memory array we have. So in the previous code, if you see, like to calculate every function, we'll check memory first, whether it is existing in the memory or not, right? So first we'll fill the memory with -1, all the elements with -1, so that we'll get to know whether we have calculated this or not. So to calculate f of 4, we'll check, right, whether we have calculated f of 4 or not into this. So f of 4 is -1, whence we have not calculated. So we have two choices. Now we'll go further and calculate this. Now we have two choices for this. One is if you included f of 4, right? If you included one of f of 4, that is 1. So if you have included 1, then you have f of 2. If you included the current, then you have -2. 4 minus 2, that is 2. If you not included f of 4, then you have just f of 3 -1, right? Now to calculate f of 2, right? To calculate f of 2, we'll check whether f of 2 is already present or not. So the f of 2 is -1, means we need to calculate. So to calculate f of 2, we'll have two choice. If you have included the second element, that is 9. So 9 plus f of 2 minus 2, that is 0, right? If you're not included this current element, then 2 minus 1, that is f of 1, right? Now you have two choices. Here also, to calculate f of 3, you have two choices. F of 3 is actually, if you include this element, 3 index is 3. So 3 plus f of 1, 3 minus 2, that is 1. If you're not included 3, then you have f of 2, right? To calculate f of 0, you again have two choices. Like f of 0 we have not calculated, right? So we'll calculate. So that is f of 0 element is 2 plus f of -2 or f of -1, whatever is the max, right? To calculate f of 1, we have either we can include one index, that is 7. If you included 7, then 7 plus f of minus 1, right? 1 minus 2, that is minus 1. If you not included 7, then you have f of 0, right? Similarly to calculate here, now we'll start calculating and we'll check. So now we had the leaf node. These are the leaf node, right? So f of minus 2 is by the condition if I is less than 0, they will return 0. So f of minus 2 is actually 0, right? And this will return, this always return 2 plus 0, that will 2. F of minus 1 is 0, this always return 0, right? So f of 0 is actually 2 and 0. What is the max? That is 2. So f of 0 is 2. So once we get the result of f of 0, we'll put in the memory. So f of 0 is 2. Now you have the answer for f of 0, right? Now this whole will return like 9 and 2. This will return 9 plus 2, that is 11, right? Now we'll come to another leaf node. So f of minus 1 is 0. This whole will return 7 plus 0, that is 7, right? F of 0, now we won't go further, right? Because it's already stored here. So f of 0 is 2, so we'll directly pick it up from here. We won't go there. So it's 2. Now max of 7 and 2 is, this will return 7. So this will return 7. So f of 1, we have the value of f of 1, that is 7. So we'll store here. And this function will return 7, right? Again, f of 2, right? So f of 2 is max of 11 and 7. So that is 11, right? So now you have the value of f of 2. So you will store it here. And this whole will return 11 plus 1, that is 12, right? Similarly, you go here. Now you will check here. Here you comes, right? So here you check f of 1. F of 1 is there. F of 1 is there. That is 7. So this will return 7. This is 3 plus 7. This is 10, right? F of 2. You will see whether there is a value of f of 2 or not. You won't go further. So f of 2 is there. That is 11. So f of 2 is 11. This will return 11. Max of 10 and 11 is actually 11. So f of 3 is 11. This f of 3 will return 11, right? And again the max of this, max of 12 and 13, that is actually your so once you get the answer of f of 3, right, you will store it here. So now you have the answer here. So that is 11, right? Now you have an answer from the left and right. Now 12 and 11, what is max? That is 12. So we will return 12. So f of 12 is like f of 4 is 12. So we will put 12 here. 12. So answer is 12, and you can directly return 12. So by this memorization, you save the overlapping calls. These are the overlapping calls, right? F of 2 is already there. F of 2 we again calculated here, right? F of 0 is here, but we calculated f of 0 here, right? So by this we actually save the code. So this is just another example of top-down approach. Fine. Now in the next lecture I will explain you the bottom-up approach for this.